Alrighty, so another hard one, GCD, previously attempted. I don't think, well, I didn't get a solution before, I guess. Sorted GCD pair queries. Hard. You're given an integer array nums of length n and integer array queries that GCD pairs denote an array obtained by calculating GCD of all possible pairs nums at I and nums at j, where I and j are in order, and then sorting these values in ascending order. For each query, queries at I, you need to find the element at index queries at I. In GCD pairs, return an integer array answer, where answer at I is the value of GCD pairs at queries at I for each query. GCD is the greatest common divisor. So by calculating all possible pairs, nums at I and nums at j, all possible pairs, sorting them. So output 1, 2, 2, GCD pairs 0, 1, 0, 2, 1, 2. I think, okay, I, j are just two different values. And they don't want you to have duplicates, so I, j and not ji. Okay, so all possible pairs of values, and then find the GCD of them. So 2, 3 would be 1, 3, 4 would be 1, 2, 4 would be 2. So the GCD values are 1, 1, 2. Queries I need to find the ith element within GCD pairs. Return integer answer where answer I is the value at GCD pairs at queries at I for each query. Okay, so one sorting it is 1, 1, 2, and here 0 is 1, 2 is 2, and 2 is 2. Not sure why you'd ever really want to query the same one. Oh, I guess it doesn't really matter what the actual overlaying program that would require this. Okay. So every possible GCD. So this is nums is 4, 4, 2, 1. So the GCDs would be, GCD pairs would be 4, 4 would be 1. 4, 2, 6. Let's go like 4, 4, and then 4, 2. That'd be 2. 4, 1 would be 1. 4, 2 would be 2. 4, 1 is another 1. 2, 1 is 1. Okay. Oh no, 4, 4 is initially 4. What am I doing? So sorted would be 1, 1, 1, 2, 2, and 4. Okay, yeah, 1, 1, 1, 2, 4. And then queries at 5 is gonna give you 4. 3 will give you 2. 1 will give you 1, and 0 will give you 1. So 4, 2, 1, 1. Okay. Okay. So I guess I assume that's going to be too slow if I actually calculate all the GCDs, 10 to the 5th. But I guess I should probably try it anyways. No, I just know it's not going to be fast enough to iterate over all the possible pair values and take the GCD. GCD is log n, then, or log k or whatever. And then to find the GCD of two numbers is like log of k. And then it'd be n squared to iterate over all possible pairings. So overall, the speed would be like initially n squared log k in order to find the GCD pairs array. And then you have another n log n to sort that array. So the question is like, how would you save time within the finding of the GCDs rather than doing n squared for all pairings? I assume I assume if I sort the values, right? Sort the nums array. Is there a way for me to leverage that? To leverage the fact that I'm doing GCD of sorted values. So if I have nums is 1, 2, 4, 4, nums sorted. Obviously you could do some sort of count or frequency, right? Like there's a bunch of ones or twos or fours. You can I guess caching values for GCD calls is too slow or doesn't give you much optimization. The cache itself is some non-negligible amount of extra processing that makes the GCD pretty equivalent if you cache or not cache. To do 1, 2, 4, 4. Well, even if you don't cache, just using counts to determine how often certain pairs occurs is probably fine. Okay, so let's go ahead and say uniques is the counter of nums. So that gives me just the frequency table, value frequency pairings of the stuff in nums. And then I could probably just work with those keys, which are the unique values of nums. Do 1, 2, 4. 1, 2, 4. Actually, what's the nums is 5 times 10 to the 4th. I'll say 5 times 10 to the 4th. So squaring that is 25 times 10 to the 8th. That's 2.5 billion. 2.5 times 10 to the 9th. I wonder, 2.5 billion. GCD of sorted values. All right, I mean, I guess I should just try to see if the counter method maybe saves enough time for it. I assume this is just going to be still too slow. let's say the values is the set. I mean, should I just use uniques.keys and then convert that to a list? Because that gives me an iterator, I believe. And then I guess I should just do vals.sort. I think this probably works. Okay. Yep. Okay, so I have my uniques sorted. I wonder if I even need to have it sorted. Does it make any difference? I guess if I am iterating over all possible pairs, it does make a difference. Because I would have to, no, actually, I don't need to sort here. Or I'll try not to. Okay, so GCD pairs. And then for every I in range n, where n is the number of values or unique values, for every j in range, I guess it'd be I after j, or I after, or j after I. So these are the unique values. Let me think. So this is all combinations of different uniques pairing off. I actually do need to do it for the same unique pairing each other. Like one compared with one or two compared with two. Okay, but let's just do this. GCD pairs. I think I want it extends because this could be multiple. Okay, so let's say this GCD of these two. I'll say current GCD is the math.gcd of val.i and val.j. So pairing those two. And then the number of ways that you can pair them depends on the frequency of them within the nums array. I think it should just be the frequencies multiplied. Like there was 2 2s and 3 4s, and there were 6 pairings. 2 times 3. So pairings would be uniques of val at I times uniques at vals at j. So the frequency uniques is going to give me, is going to map the value to the frequency. So the value itself is vals at I, vals at j. Okay, and then it'd be GCD pairs. Extend is the way to add like a list of elements rather than a single element to the array. So it would be current GCD times the number of pairings. Okay, so that's for uniques versus uniques. And then if the number of times the value I occurs is more than once. So it's greater than 1. Then it can pair with itself. So how often would it pair with itself? So if there's like 2 4s, it'd be 1. 3 4s, it'd be 2. I guess it'd be combinations, right? So it'd be 2 times, or n, the frequency times, I think it's frequency minus 1 divided by 2. 3 times 2 divided by 2. Yeah. Pairings is uniques vals at I times uniques. Maybe I should just have a variable for this. Let's say frequency is vals at I. So this would be frequency versus the frequency of j, of vals at j. And this would just be frequency times frequency. I guess I could make another variable here. It's whatever. Probably making too many variables. I think I could actually do this without the if statement. Pairings of the number of pairings here would be frequency times frequency minus 1. I guess no, actually, I think I do want an if statement here. So if the frequency is greater than 1, yeah. Frequency times frequency minus 1 divided by 2. And then GCD pairs. If I'm doing the GCD of a number itself, that's just 1, or no, that's just the number itself. So it's going to be extend the current number, which is vals at I. Vals at I times, no, oops, I need brackets here, times the number of pairings for this. Okay, and then let's go ahead and just print out GCD pairs, see if it's correct. Yeah, that seems a little long. Little being way too long. Oh boy. N is the number of values. I, oh no. J, current GCD, unique values at J. Current GCD times pairing. Okay, let's go ahead and just print out what these things are doing. Is my calculation for the number of pairings incorrect? So 1 and 2. Oh, I'm an idiot. The frequency table is uniques. It's using the counter, not the fucking. So stupid. Okay. I think that looks what's going on now? Why is it not having any GCD pairs? No one. Huh. Uniques. Okay, yeah, I did the same. Incorrect. GCD. The frequency is uniques of vowels at I. Okay, maybe. So this should be. Well, what am I doing? I'm such an idiot. The current GC is going to be the GC based on the two values itself, and the pairings is based on the frequency. Okay, maybe that might be right. Okay, 1, 2, 1, that seems right. 2, 3, 2, 4, 3, 4. That seems right as well. Okay. So then I would do GCD pairs sort, and then I would do each query. So for every, actually, I can do this with a list comprehension, I think. So the answer I is going to be GCD pairs at I for every, actually, I think it's GCD pairs at queries at I for every I in range of the length of queries. I think that's right. Okay. Probably too slow still. Yeah, looks like it's too slow. Yep, 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 yep. Okay, so how long does this test case that it ended with take? I assume a single test case is not going to be. Okay, time limit. It goes time limit exceeded on just this test case. Interesting. Okay, let's go ahead and print out the length of this test case. How many elements are there? 5,000. So every element. I see. That is the upper limit, right? Okay. Alrighty. So, so in this case, I cannot take the GCD of every pairing. That's just too slow. Do 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 do. I mean, I could do something. Um, yeah. So Could I what can I do here? So it's already sorted for me, but it wouldn't take that long to actually do the sorting. What else could I do here? One, two, three. So how would I leverage the fact that it's sorted? One, two, three, four, five, six. I mean, clearly if I have GCD of 1 and a number, then it's just 1. If I could identify the prime, then GC of them would just be 1 or that prime number itself, right? I could do a prime factorization of every number, maybe. So find prime factorization of every number. Uh, actually, I don't know. To find the prime factorization of every number, I think that's lower than log of k. Or prime factorization of a number, I think it's slower than log of k. But if I were to have an iterating loop, to find the prime factorization of every number between 1 and 5,000, could it be not 5,000, is it actually? It's is it 50? Yeah, 1 in 50,000. I wonder if there's a way for me to do that more quickly. 50,000. 1, 2. So it would be what would it be? 1, 2, 3, all the way up to 50,000. That's a lot of numbers. If I were to divide by Oh, 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 oh. What if I did something where hmm, 2, 3. I mean, it seems like I would need to have the prime factorization of every number. Or maybe I need to calculate it somehow. 1, so let's say that 2 to 10 was removed. And the list was just 1 and then starting with 11. 11, 1. Okay, maybe 1 through 10 is removed. Then I have 11, 12. Those are relatively prime. And then I have 11, 13, 11, 14, 11, 15, 11, 16. Hmm. So if I take two numbers that are relatively prime, their GCD is 1. Let's say I have two numbers where it's not relatively prime. So let's say nums is say 12, 14, and 20. So 12, 14 is going to be 2. 14, 20 will be 2. 12, 20 is going to be 4. And those are the GCDs of the pairs. 2, 2, 4. So if I know that 12 and 14 give me a GCD of 2, and I know that 12 and 20 gives me a GCD of 4, could I somehow say that 14 and 20 is 2? I don't think so. Well, do, 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 do. All right, I guess this is where the streak ends. All right, time to